Okay, I guess I'll go ahead and get started. My name's Kyle Haley, and I've been working on performance monitoring on databases for a long time, so something I'm really excited about. And I joined Amazon about 2 years ago, which sort of changes some of the paradigm as far as performance monitoring for databases goes. So I'll talk about some of the ways we architected it and the ways we expose the data. Some of it will be new if you use enterprise managers. Some of this will be old hat, a little mix of both. And I have a live demo, but I don't think we're going to do it because it's not fitting on the screen right, but I have it all in the PowerPoints. So we'll see what we can get to. One of the things I want to say is I'm really grateful to be here, invited to talk. I'm really grateful for this community, Oak Table. It's been a lot of fun connecting with these experts over the years, and I've learned tons. It's really helped my ideas go faster when I have these people to reach out to, or they inspire me, or I see how they do things. So the content in this talk, so basically 4 parts. I want to talk about the cloud. What's a cloud? How do we fit in? How does performance monitoring fit into the cloud? Then what kind of data do we collect? And then a method of collecting data called sampling, and then user interfaces for this data. So first of all, on the cloud's going to be where we're going to be putting these databases. So not on premises, not hosted, but actually in the cloud. That's the infrastructure we're going to be working on. And I'll talk about this in a little bit more detail, but cloud's basically automated, accessible, elastic, and it's immediate. The data, so this is database monitoring. So we're gonna need the OS, databases run on OS. We need to make sure the operating system's healthy, and then the database statistics. And we'll look at which of those statistics that we wanna look at, because the amount of options, the amount of data we have access to is overwhelming. So we have to pare it down to handle it. And one way to handle that data or maybe pare it down is to focus on sample data. So multidimensional textual data that we can make time series out of. So we'll talk about how that works. And then finally, we'll talk about the user interface. How do we expose this data? And the key is just basically this one graph we'll see if you've seen it in Enterprise Manager. It's the load graph. What's the load on the database? And what kind of load is it? So first of all, what's the cloud? I mean, I grew up in the Oracle world, like, on-premises, big machines, big databases, and I just joined Amazon 2 years ago. So out of 25 plus years of my career, most of it's not been involved with the cloud. So before I joined Amazon, I only had a vague idea of what the cloud is. But I remember over the years, past years, walking around open world and hearing people, especially a few years ago when this was getting big, people say, oh, the cloud is just hosting. It's sort of funny. Like this, we're just reliving history over again. But is cloud really hosting? What is cloud? If somebody asked you, can you come up with the definition? And a couple of years ago, I didn't really have a definition. I had some ideas, but I just basically looked it up. So this is from NIST, the National Institute of Science and Technology. They have 5 points on what the cloud is. First of all, it's internet. It's network access. The idea is that we can access it from anywhere. Next is on demand, which is probably one of the coolest things to me. It's self-service. So instead of having, argue with my managers about what I need to buy and getting purchase orders and having stuff delivered and on pallets and unpacking it and plugging in and installing the software, installing the database, basically I just pull out a credit card, log in, go to a URL, put in my credit card, say I want an Oracle database of this size with backup, failover implemented, push a button and it's done. For me, that's pretty incredible. One of the things that's been a challenge as far as doing performance monitoring on different databases is if I'm going to do performance monitoring, I need environments that I can test on. I need a SQL Server database. I need a DB2 database. And this has been a bit of a pain in the neck. I mean, I'm a dyed in the red, whatever Oracle guy. So I don't know how to install DB2. I don't know how to install SQL Server. And when I was at companies like Embarcadero, where we're building these monitoring tools, I'd have these environments and they're pain in the neck. And now, at Amazon, SQL Server, I just go in and say, I want a SQL Server database. 5 minutes later, I've got one running. I don't have to know much of anything about it. It's pretty cool. So the idea is, with the cloud, it's one-click setup. I don't have to worry about configuration. I don't have to worry about managing it. It's automated. It's pooled, so customers are using resources on their shared resources. But the cool thing about this is I have immediate access to it. We don't have to order hardware. It's all set up. There's pooled resources. I just need to carve out my niche in that pool of resources. And then it's elastic. I hate to admit it, but I mean, one of the big attractions of the cloud is it's elastic. I don't have to know ahead of time how much resources I have. I'd say I've been at Amazon a year before I actually did something where I actually made my instance size, my host size larger. But it blew me away, though, even the first time I did it. You push a button, I say I want a larger machine. Yes, there's a balance operation, but then I'm up and running with a bigger machine. That's really cool because I don't have, I mean, when I was first looking at my set of machines, I was like, oh my God, these machines are too small. I'm going to have to migrate them over to another machine. But no, I just hit a button, get a bigger machine. A lot of pressure off. So I don't have to worry about the size of the machine, the storage. And then it's a service. It's paid by the drip. Basically, instead of having to pre-allocate all this finances and revenue, whatever, to pre-buy stuff, I can just basically, pay as I go. So it's much less onerous to get started with something. So that's a basic idea of what the cloud is. How many people are not using the cloud, are not involved in the cloud at all? Okay, one. Anybody else? Anybody else want a minute? Two? Does anybody not know what RDS is? Is that a new term, RDS? Okay, who knows what RDS is? It's most people. So RDS is where I work at Amazon. It's basically managed databases in the cloud. So that's where you just pull out your credit card, say, I want this database on this size machine. And so what I'm going to be talking about today, and this is because of what I have to deal with at work, the databases I'm going to talk about are Oracle, SQL Server, MySQL, and Postgres, because that's what RDS supports. These same ideas of like what the kind of data we're going to capture and how we're going to present it in a UI, it applies to any database. Like I've done it before at Embarcadero, we did it on DB2 and Sybase. You could do it to any database that had the right kind of data exposed. You could even do it with operating systems. I mean, one of my dreams is to have this kind of same data visualization on operating systems. But where do we put it? How do we monitor a database? So, I mean, the Oracle world, typically we have a machine, and on that machine we have a database running on it. It's in some data center. And like with Enterprise Manager or with SQL Server's tools, basically what they do is they stuff the data, the performance data that we're collecting, we stuff it into the same database we're monitoring. So that's one approach. And that's sort of what we grew up with. I mean, in the beginning, we didn't have access to a bunch of networked machines or resources or cloud. So we, put the data we want into the database we're monitoring. With other tools like Solarwinds or Quest or even like Oracle Cloud Control, the idea is to have some other machine that has a database running on it, and we load the data into that machine in the same data center. Then we're getting to the world of cloud. Anybody use Vivid Cortex here? So Vivid Cortex is known for its a MySQL monitor, but it's a pretty cool MySQL monitor. But what they do is they host their solution in the cloud, and you give your connection information in your data center on premises. So it connects into your database, loads the data into the cloud, and then you have your monitoring interfaces in the cloud. But what I'm going to talk about and what I'm doing at Amazon, the team I'm working with at Amazon, is full native cloud infrastructure. So our databases, RDS database, is already in the cloud. All the infrastructure we implemented to do the monitoring is all in the cloud. So basically, as an end user, I can access this from anywhere. And this has some cool challenges and some cool advantages. One of the advantages is these database hosts, where they're AMIs, they're machine images that we've put together at Amazon. So we can pre-bake an agent into it. One of the challenges with monitoring is how do we do it? Do we use the agent base or not agent base? And one of the challenges with agent base is, as a customer, I have all these agents on machine, and it's usually a lot of configuration, a lot of version. They tend to be brittle with versions. If you get the versions wrong, this agent can only connect to this version. It's a lot of maintenance, and I have the same reaction. I tend to stay away from monitoring solutions that want an agent because it's just a pain in the neck. But in RDS, we don't really know what's in the machine. We don't have to take care. It's all taken care of for us. So there's an agent already there. I don't have to manage it. There's very limited number of operating systems involved, so we don't have a big matrix of different things that we have, different versions we have to support. So one of the questions, though, as far as monitoring systems, do we push or pull? Does our centralized monitoring system connect and pull data out from the targets, or do we ask the targets to send data in? And one of the cool advantages of pulling it out of the targets is we don't have to deal with agents. I have a centralized system with intelligence. It reaches in through JDBC or something, pulls out the data I want. So there doesn't have to be an agent on the box. But as I mentioned in the Amazon setup, we already have an agent. And it's instead of having this complicated centralized management where I have to know all my targets, if we already have the agent, it's much easier to manage having these agents push the data into our centralized system. So the system doesn't need to know about all our targets until they send the data into it. Now, this is one of these things that sort of blows me away is how do we set up a system that's going to scale to what customers demand at Amazon? And this infrastructure that's going to be receiving all this performance data, we're talking hundreds of thousands of databases. And I think in a few years, it'll be in the millions of databases. That's some pretty big infrastructure. So how do we build an infrastructure that scales like that? And the way we've done it, and ideally somebody like Jeremiah Wilton, some of you might know him, might do a blog on our infrastructures because it's pretty interesting. It uses 14 different Amazon services. So I'm just going to go over the high level here. But basically, all these agents are sending their data to Kinesis streams. So it's streaming data. So we can send in a lot of data fast. Then on the other end, we have the consumers that are going to take the data and pull it apart and store it. And part of that, those data consumers, they also put it into granules. So like we have 1 second data coming in. We put 1 minute roll up, 5 minute roll ups, 1 hour roll up, 1 day roll up. So these consumers are breaking the data apart and just putting it in storage. And so there's different levels of storage. You actually use 3 levels of storage. But the idea is you want some like fast caching. So like the data that's coming in hot from the targets goes into the fast cache data. When a reader comes out, it'll be available immediately. Generally, the data in our systems is like a few seconds behind the actual target we're looking at. But then we have a lot of data. We keep it historically. So then we're going to store that to long-term storage. So the longest-term storage is S3, so cheap long-term storage. And then basically using EC2, using the hosting system, we have these reader systems that read the data out. So when a user comes in, we read the data out of these storage subsystems. So that's basically the architecture. And this architecture has economy of scales. With all these tens of thousands, hundreds of thousands, millions of databases, we can provide these services fairly cheap per database. It's elastic. As more and more systems come into this internal architecture is elastic. It grows on its own, and it's all automated. Now it's going to give us some access to some cool things. First of all, the DB host that we're monitoring, we put almost no load on it. So that agent is about, my testing is about 1/10 of a virtual CPU, so very low load. All the data is coming off the box. So when I come in and monitor that database, I'm not actually interacting with the database itself. I'm interacting with the infrastructure. So there's no load when I come and look at the data. And then if we have all these databases in a fleet and all our data is aggregating to a centralized system, we're going to have opportunity to see things like, is there a shift in a resource in a availability zone? Is there a slowdown in availability zone? What kind of slowdown? You know, did the IO slow down across a bunch of different databases? We can see things like that. We can also see what are the most frequent wait events on different types of databases. What's the most frequent wait event on a Postgres database? Or on this version of Postgres? What's this version of Postgres do compared to this version? I don't know how many of you remember, but Annual Kolk used to have this website where you could upload your bstat, estat kind of. And the thing I was most jealous about is he had access to all this data. He had, what was happening in different versions of the database. I wanted to see all that. Well, now we have it. I mean, I don't have direct access to it now because one of the challenges here is security. We can't see we can't see your SQL statements or anything like that. But when it's high level, like aggregate performance data, we're allowed to see that. So we're still building those systems, but I'm pretty excited about it. So then the question is, what do we monitor? So that was our infrastructure. On what to monitor is basically 2 parts, right? We use machines, we're on a host. So that host has to be healthy. Then we put a database on it. We'll make sure the database is healthy. So I think the host should be fairly straightforward. I mean, there's 4 basic domains: CPU, memory, IO, and communication, network latency. And then on the database, this is more debatable. But the things I want to see are what's the load on the database? From that load, what are the SQL generating that load? Who are the users running it? And then what are the objects involved? Now, this sounds simple, but it's actually somewhat challenging. Has anybody ever seen this picture before? I see one. This is a picture from Gregg, Brendan Gregg actually spoke here a few years ago, but he's this amazing like Unix tuning kind of guy, involved with dtrace and Solaris, works at Netflix now. But this is a image he has of the different tools and different layers of Linux, and for us performance monitoring, where you can get data out of those tools to see what's happening at those different layers. And the only reason I'm really presenting, I mean, it's really cool. I mean, you can have some fun looking at it, but the main reason I'm presenting it right now is there's a lot of data available. It's overwhelming. I mean, I don't know how much time, you could probably spend a semester going through all these tools and data and trying to figure out how they work. Now, Brendan, before we get to this, this is from CloudWatch at Amazon. And the reason I'm presenting it here is because and this is what I see often with kind of dashboard monitors. There's a bunch of graphs with some lines, and I'm like, well, what does it mean? I don't know. I mean, am I supposed to correlate some of these graphs? Are they supposed to be related? And what kind of correlations do I make? How do I do it? What do I do with this data? I find it challenging. So this is a solution from Brendan Gregg. Again, the same guy that had all those tools, the different layers in the Unix operating system. He's broken it down, the same 4 groups that I mentioned earlier. We have CPU, IO, network, and memory. And so each of those is a row, and then the columns is going to be utilization on the left, saturation in the middle, and then the errors on the right. So he's broken it down into something I think sort of pretty cool and relatively, a lot more simplified than what we saw earlier. But what I like to say is, for me, this is still a fair bit of information. I mean, I want to know pretty quick what's happening on the system. So this is just the operating system. Now we have the database. I don't know how many of you have taken one of these reports into a meeting and been like, look, here's the problem. I found it, and this is what we can take as far as remediation goes. And then the next hour, people continue to argue. These things are a little crazy. And, they're full of things like ratios, cache hit ratio, latch hit ratio. Sometimes I feel like it's reading the tea leaves or like the Irish ruins, trying to figure out what's going on in the database. It's a bit overwhelming. But there's a lot of data in the database. What kind of data do we want to see? I want to see system statistics. What are the statistics? What's happening in the database? I want to see what the wait events are. Now I might want to see these per session. Well, in Oracle, these numbers are actually very low. In Oracle, there's I think over 1,000 wait events now, and there's a couple hundred statistics. So if I collected those 1,000 wait events and those several hundred statistics per user, and let's say there's 100 users, I'm talking over 100,000 data points per collection. That's a lot of data. Now, if I want to collect fast, maybe certainly not once a second, once a minute. That's like a lot of data once a minute. And that's just the sessions. What about SQL? Like thousands of SQL. Well, what about objects? In a financial system, there could be tens of thousands of objects to monitor. It's a lot of data. And one of the most disappointing things about the data, or something like AWR report, is it often doesn't give us what we want. It doesn't draw the correlations. There are different sets of data. I might see there's a CPU problem, but I don't necessarily see who's causing the problem. I might see in the wait events at the top some sort of weird wait event, or say like a latch free or something, but I don't know what latch it is. But basically, I want to know, given a bottleneck, who's the user involved, what SQL is involved, and what objects. And that kind of correlation is what I want to get. And with the counters are not very adaptable to that. They don't really provide that to us. But what does provide that is sampling. So let's talk for a minute about sampling. So sampling is a lightweight but powerful method to get the performance data we want. And it answers the question. It's going to answer the question, is there a bottleneck? If there is a bottleneck, where's it coming from? What's SQL? I like this quote on the bottom. It's by Charity Majors, the CEO of Honeycomb.io. Has anybody looked at Honeycomb.io? Nobody? One person. I want to look at it. It sounds like they have a multi-dimensional database. Have you played with it, JB? But it'd be nice to have if there was some sort of a generic multi-dimensional database you could store data in. But anyway, she says, if you're not sampling it or aggregating your operational data, you're doing it wrong, almost categorically. So sampling, probably many of you are already familiar with it. All these databases that we're talking about today, they all have these structures that say who's connected to the database. And in that structure, they have if they're active or idle. And if they're active, they have what SQL they're running. They have what host they're coming in from, what their username is, and what state they're in. So we can just sample this. So for each connection that's active, we come in every second, get that data, and use that data to build up our load model. How many people using Postgres here? Fair bit. MySQL? Fair bit. Anybody? Bernard Druveau, I think, just released a package on Postgres for like Ash for Postgres. Anybody try that out yet? Looks pretty cool. But Postgres has this view PG stats activity. Basically, it's who's active. It's like Vidal said, who's active, what SQL are they running, what wait event are they waiting on. MySQL is a bit harder. MySQL, you need a couple of structures, threads and threads and wait currents. Wait currents has the wait, and the threads has the SQL. But when you try to join them, they're not transactionally consistent. So what we found is that the data comes out pretty messed up. So what we actually had to do at Amazon is go into the kernel of the database and recode it, make a structure that had both those parts in it, a single structure. SQL Server, there's a couple of options to get this data. Sys processes or DMExec requests. And then in Oracle, there's VLR session. So sampling is like taking a movie. We sample every second. What happens between our samples, I don't know what happened. So this drives a lot of people crazy. People are like, well, I'm missing data. I need to know what's happening. But like when we go to a movie, it's 24 frames a second. I don't know what's going on in between the frames, but I don't even know, have no perception of that. And what we found is that sampling once a second is a pretty good frequency for describing the activity on a database. The other sort of pushback we've seen over the years is sampling once a second. So one reaction is we're missing data. I need more data, we're missing it. And the other reaction is, wow, that's way too much data. So like when this project got kicked off at Amazon, they're like, well, we have these hundreds of thousands of databases, and if we're collecting once a second, and they have multiple active sessions per database, we're going to be overwhelmed with data. But the thing is, the majority of those databases are practically idle. And even if I have hundreds or thousands of users connected to the database, usually you see very few active, maybe 10. If it's getting in the hundreds, it's sort of a rare case I don't see very often. So here's an example of 4 users. Time goes from left to right. And these 4 users are running 3 different kinds of queries. Little vertical black lines, that's when I sample. So what we can see is that first query on the bottom is a multi-second query. So any query that takes more than a second, we always capture it. The query above it, though, is short, it's sub-second, but we run it fairly frequently. So we capture a lot, but we'll miss it sometimes. If a query is run really fast, it's really fast, but it's not run very frequently, we might miss it altogether. But the thing is, that's cool. I don't really want to know. It's noise. It's not putting any pressure on my database. It's running fast. This sampling method actually is a natural filter for a lot of the noise, so it concentrates on the stuff that's most important. So the idea is a connection's idle, a user submits a query while the query is being executed inside the database kernel. That's the active time. Once it's finished and it returns its result set, that's when we're back to idle. Graphically, if I show this activity, sort of when I'm in a green rectangle, I'm active, otherwise I'm idle. Then we're starting to see sort of the graphical presentation. And if we just stack those, it's showing our level of concurrency, how many connections are concurrently active. I find most people seem to get this pretty quick, but I'm still looking for better ways to explain this because I still get a lot of questions from people who've never seen it before. But the cool thing is, I don't think you have to think about it too much. The idea when we first sort of kicked it off, like JB's here, when we first joking about it, it's like, click on the big stuff. If you see something big, then it's bad. So to simplify the interface. Another thing that's a little confusing is, so if this is our active session graph on the bottom, this shows continuous activity. I don't really know what kind of continuous activity that is. In this case, I have one user running a long query. It's continuously active, and the result looks like one active session. I could have 2 sessions for one's having a 5-second query, and another's having a 5-second query, but down in the active session graph, it looks like just one session's active. But it's actually 2. I don't see that. Same thing, instead of executing a 5-second query, if I'm executing a 1-second query, so one guy does it 5 times, the other guy does it 5 times, over 10-second range, it balances out, it looks like one active session. Now this is actually the actual samples. What we do is we take averages though. So that green square on the bottom is a 10-second average. Well, what's happening to that 10 seconds above? 2 sessions are executing a query 5 times. They execute it in parallel, in tandem. I don't know that. I just see that the result is one average active session. Same thing, if I have a 10-second time period and 10 users execute a 1-second query, the result is just one average active session. So just getting an idea of what the input and output can be like. But so far I've just been talking about idle or active, but we can talk about more finer grain information than that. And the kind of information I'd like to see is what kind of activity is. So here I've just put 3 colors up there: green for CPU, blue for IO, orange for wait. The idea is when a query starts, it gets submitted, this first query is executed on CPU the whole time and then returns a result set. The second query, I come in, do some CPU, and then I'm missing some data. So I wait for some IO to finish, get my IO back, do some CPU and release. And then finally, I have a query comes in and does some CPU work. Then it has to wait for some resource, gets the resource, and then it does some CPU and returns the result set. So with this kind of color coding, I can start to see more about what's the personality of the system, how well is the system running. So here, graphically, I've just taken that activity and stacked it. So we keep CPU on the bottom. We'll see why in just a second. And I see some IO and some wait time. Now we're collecting this every second. If we have a wide graph, and that, like in Performance Insights at Amazon, by default, it's 1 hour. If I have 1 hour of 1 second data, it's going to look really fine and messy looking. So we take the average. In our case, in Amazon, I think it's once every minute. So every point is an average over a minute. I think in Enterprise Manager on top activities, 15 seconds. So those are averages, and the average, you need to know what the bucket width size is. So now we can see that the load is rising and falling. But here I have the same old question: is that load high or low? Is it good or bad? Well, that's where we add this max CPU line. So there's a dashed red line here. In Amazon, we talk about virtual CPUs or vCPUs. It's the CPU capacity of the box. Above that, if I have more demand for CPU than that line, then I know there's CPU contention on the box. And generally, whenever the load goes over that line, that's showing you there's some sort of bottleneck. Whenever there's an amount over the line, we know that there's users waiting. And when there's users waiting, it's an opportunity to tune. So now we have a simple set of heuristics. We have this value average active sessions, number of concurrent sessions over a bucket, over our average period that we're using. If AS is less than 1, we know the database is not blocked. In order for the database to be blocked, there has to be a user that's blocked. If users are blocked, they're in a state of 1 average active session. They're waiting. They're not moving forward. So if your value is less than 1, the database is not blocked. People are making progress. If AS is near 0, the second point, then the database is basically idle. And this is really cool. This is an important piece of information. On the next point, number 3, when AS is less than the number of CPUs, we know we have CPU available on the box. Now, this is I'm talking about Amazon. In the case of Amazon, you're the only thing on the box. In RDS, you have one database on your machine, so nobody else there's no other, you don't have access to the OS. You're not running some other programs. Outside of an environment like that, you need to make sure that nobody else is using the CPU. But if you're the only thing on the box and your AS is less than the number of CPUs, there's CPU available. Although whenever AS is greater than 1, there could always be a block session. So there's always opportunity to drill into that. The last point, when AS starts to go above the number of CPUs, then we're getting into bottleneck territory. And finally, the last point, when AS is much, much greater than the number of CPUs, there is a bottleneck. Now, I don't know how many times, when I was a production DBA, I'd say every second day, every third day, I get the app guys calling me up being like, the database is slow, the database is slow. And often I would know it wasn't slow, but the question is, how do you prove that? How do you prove it quickly and powerfully? And I mean, if you want to whip out your AWR report, you're still going to be arguing for a long time. But when you come into an average active sessions graph like this, so this is in Amazon, that graph is empty. The database is idle. There's no pressure on it. So if there's a slowdown in the application guys, it's outside of the database. And so you can relax and enjoy the moment. It's actually funny, when I first started implementing this stuff with TCL/TK, I was able to get to the application guys first, because I could see when the application load dropped. And when it dropped, I knew there was a problem, like the application servers went down. So I called them up so I could sort of turn the tables around on them. It's a nice day. Average active sessions is also good for sizing. I mean, one of the anxiety-provoking things, I guess, when building a system or going to the cloud, is like, well, what size machine? I come into Amazon, they have all these machines. Well, what size do I pick? Well, when I look at the load chart, like on the first one on top, there's a little bit of green CPU, and then the dashed black line is the CPU capacity of the box. This box has a lot more capacity than I'm using. If my load never changes, if it's consistently like this, my box is over provisioned and I can make it smaller. On the graph below, though, I constantly have these little batch jobs that are spiking up way above the CPU line. So those are bottlenecks. In this case, I could actually put this load on a larger machine and it would run faster. So finally, how do we expose this data? I think everybody knows this. Top activity in Enterprise Manager. Solarwinds used to be Confio Ignite. How many people use Solarwinds here? 1, 2, 3, 4, 5. A lot of people. It's pretty cool. I mean, maybe it's things have changed. Things that sort of throw me a curve. Like when I installed this, it took like an hour before I got any data. It wasn't immediate. Like had to load up a certain amount of data. And also the way they showed data, at least last I looked, is seconds per second. So how many seconds did my connections wait within this bucket? Which I find seconds per second seems like a weird metric. I like the average active sessions. I feel like it, for one, it's normalized. If you tell me average active sessions, I can always tell you, I have an idea for what kind of load that is. If you tell me how many seconds, I don't know. I need to know the bucket size. I need it normalized into average active sessions. And then there's Quest Foglight. How many people use Foglight here? A couple. I don't think they, I think the dark green is, yeah, but the other one's. Yeah. Well, no, they said, I mean, in Confio Ignite, they say it's total number of seconds. They don't do the division.
Oh, they don't?
Yeah, so you have to do it yourself. That's my impression, but I mean, I know maybe some people use Confio can respond. I know people seem to like it. I've heard a lot of good feedback about it. Tell us how you feel, JP. I agree, but I'm not gonna, I'll be a little bit softer. This is Lab 128. How many people use Lab 128 here? Nobody uses Lab 128? Well, I think it's really cool. I mean, in this day of web interfaces, it's a bit old school. It's a fat client, but it's super fast. Yeah. And this is DB Optimizer. Worked at Embarcadero. So this was one of the first forays into other databases. We also did SQL Server, DB2, and Sybase. But I think it's really cool, like this load interface compared to like other interfaces. This is a batch job. Its label's been run 4 times: run 1, run 2, run 3, run 4. In the first run, I had my log files on a slow disk, and that orangey color is log file sync. So I'm waiting a lot for my log file syncs. Then you see a little red checkpoint, this little blue thing. You can see that's where I recreated the new log files on a faster disk. Then I reran the same load, and it's a totally different, looks totally different. Now it actually takes longer. You can see it's wider, and that bricky orange is buffer busy waits. So in this case, the table only had 1 free list. I moved into ASSM table space. I didn't have to configure free lists. Ran it again, run 3, and now it's all brown. Brown's a configuration grouping in Oracle waits. And basically my log files are switching too much. They're too small. So you can see some dark blue on the far right. That's where I recreated and made bigger log files. And then I ran it a 4th time, and it's all green. So I've gotten rid of all my weights. You can see how fast it is. It's smaller. And you can see some more information. That red line is the CPU capacity of the box. I was demanding twice as much capacity as the box had. So if I put this on a larger box, it would run twice as fast. So, I mean, I just think that kind of, performance is fun, right? And like being able to see this information quickly is fun to me. JB and I used to always joke around, nice if we could make this into a video game. And then you just go put it in a bunch of video arcade parlors and have kids tuning your database. Sort of like the Matrix. So I'll show some use cases. This is Performance Insights at Amazon. So here we have the load on the top SQL on the bottom. In this case, I see the max CPU lines, that dashed black line is at 2. I've got this big green spike. It's a bottleneck, so it goes way above the max CPU line. What is it? I look in legend, that green is CPU. So basically I have a CPU saturation where I'm demanding a lot more CPU than is available in that bottleneck. So I can find out where that's coming from. I go to the top SQL. If I got rid of all the SQL below the first one, it still wouldn't have much of an impact on my system. So I know that I need to put all my effort in that first SQL statement. It's a function, it's a minute rollup, so I have to go in and I see if I could tune that function. I can also click and drag and zoom in if I want a better view as to what's going on. So that was a CPU bottleneck. What about what's a weight bottleneck look like? So here I have some other color. There's a spike. I can click and drag. Whoops. Click and drag, and I zoom into that. What we've added is flyover help on the legend. So like, I'm an Oracle DBA, and I look at this as a Postgres database. I don't know what these weight events are, and weight event names have never been very descriptive on any of the database providers. So we have pop-up documentation that explains what it is. Basically, this is waiting for writes to stable storage. So it's sort of like a log file sync. And if I look down what's happening, it's all coming from that first statement, which is an insert. It's insert 3 fields into a table. Basically, they're single row inserts. These are JDBC connections. They're doing auto commits. So basically, I'm committing after every single insert. So if we wanted to tune that, basically, I'd batch it, do 50 or 100 inserts to reduce the weights on that. And then there's some other dimensions in this interface. In the legend on the top right, there's a pull down little arrow. By default, we show weights because I think that's the most powerful way to show performance. But I can pick other things like SQL. So the top now, the loads is the exact same, but the color grouping is different. So now it's showing me the top SQL. On the bottom, we have the same dimensions. So by default, it's top SQL, but here I've chosen hosts. So typically in a database setup, we have a database with multiple application servers, and I balance that load across the application servers. So 2 things, I want to know that the loads balance across those application servers, and I want to know that they're running the same load, that everybody's installed the latest correct software. In this case, the load's pretty similar. It says the first one's an average active session of 1.23, and the one below it's 1.09. So loads are similar, but by the colors represent the different SQL on the top. They're running completely different sets of SQL. So this might be an indication that maybe my last code deploy didn't go correctly. So we're getting near the end. I want to sort of mention some of the advantages of cloud native monitoring, because we haven't really dug into them. They're more future. These are like future deliverables. But we can see these trends. We can see trends across regions. You know, is there a slowdown across certain types of databases or in certain areas? Or is there certain versions performing less, slower than previous versions? I like to know, what's going on. What are the top wait events per database? Which ones are the ones people seeing the most? And that will help us know which ones do we want to try to optimize, which ones do we want to try to document. Are there some databases with some bizarre wait events out there? Maybe we want to reach out and work with those customers. Once we have a lot of data across a fleet, we'll be able to say, does this database fit? How does this database fit into the norm? Is your database unusual? Is your database seeing performance problems that we've seen before? We'll be adding, like Adam and Oracle, of course, we'll be adding diagnostic feedback. We see a bottleneck, we think you should take this action. When we have a fleet, we'll be able to monitor, did that corrective action have an impact that we expected? So we'll be able to build up these new models about what's happening with feedback from other databases. So this is what I'm super excited about. Be a very interesting future. So in summary, basically cloud's a new paradigm. It's automated, accessible, elastic, immediate. I mean, I love the immediacy. I love the lack of pressure. I just pull out my credit card, blow up, spin up a big machine, use it for a little while, and I can throw it away. The data for monitoring performance can be overwhelming. It's amazing what I see people still collecting. The solution, in my opinion, is sampling. Sampling reduces our set and allows us to do correlations that are some of the most powerful things we can do. And then the UI, how do we expose this? The load chart makes it really simple. And then if we add a top SQL table to the load chart, then we can see where that load's coming from. And by color coding thing by weights, we know what kind of bottlenecks we're seeing. So the last thing I want to show, which is what I wanted to spend more time on, but I just started this, doing these load tests last Thursday. I wanted to show the same load across different databases in the UI, because I think this would be cool, because then we can compare Postgres and MySQL and Oracle. I've had load running on these databases for a while, but I spent like last Thursday normalizing load so it'd be as close as possible across the different databases. So this might be something more interesting if you're curious to go dig into the slides. But so this is Aurora MySQL. So Amazon has its own distributions of MySQL and Postgres optimized for their infrastructure, and it's called Aurora. So there's Aurora MySQL and Aurora Postgres. So this is Aurora MySQL. One thing I'm looking forward to, and it's going to take a little work, is making the UI look the same with the same type of load across the same databases. So this is basically MySQL, and we can see that light orange is like log file commit, but this is Postgres, so it's IOXAT sync, so it has a different name, but by color I know it's the same. Here's Aurora Postgres, so different database, but you can see basically the colors are the same. There's a little bit of red additional here, or red's locking. So the idea is I can see the difference between these two loads. It's the same, running the exact same code on these databases with the same level of concurrency. And I can see basically the load's a little bit different. Very similar, but a little bit different. Now, these two slides were we've already started color coordinating the wait events. The next ones we haven't. So this is a RDS Postgres. So the colors look a little different because we haven't mapped them yet. I'm looking forward to getting a standard color mapping across all the databases. But you can't see the load. By looking at the dashed black line, you can see how the load compares. So that's about twice as big, a little bit more than twice as big. Now the load's getting low, relatively low compared to the other databases. So this is MySQL. Again, we need to coordinate the colors. You can see it's using less CPU than the other databases. And Oracle. Oracle's using pretty low on CPU. And so that commit should be that orange color. So then it would look more like the other databases. And just a little grid that shows the comparison of the same load across these databases. I sort of color coordinated the colors, so the orange is like log file sync, green for CPU, red for locks. And that's basically it. But yeah, each database has a different kind of shared memory. The question, how do you make sure we're comparing these databases apple to apple? Well, on the code side, I'm running the exact same benchmark. So I'm using JMeter, running the same queries, same data set size. We're collecting the data in the same way, sampling every second, collecting the same type of data, who's active, which SQL are active. It's all the same methodology. The only difference is the name of these wait events.
No, I'm talking about how you configure the database, each different database, and allocate configuration parameters.
Oh, so the question, how do you make sure, okay. So how do you make sure these databases are performing the same way, the same parameter files? I'm not doing I'm not necessarily doing a performance benchmark. I'm not racing them against each other, but I do want to see what's the sort of profile. But yeah, if you're doing a rate, if you're like, a bake-off benchmark, yeah, you want to get in there and change your parameters and eliminate these, eliminate the weights as much as you can, optimize the CPU as much as you can. Yeah, I didn't spend time messing with the parameters. I just spun the data, did the default RDS databases, and I ran this load on them. These are all the same instance size, yeah.
The max CPU on the y-axis, how is it value calculated?
So it's the number of vCPUs. So vCPUs is basically how many process, per vCPU you can have process running. So the number of vCPUs is how many concurrent processes you can have running.
Okay, so it doesn't dynamically change depending on
No, the vCPU stays is attached to the host machine you're on. So if you upgrade your host, it'll get a new one.
Which leads me to the second question. It's so easy to use the credit card to scale up. Why would you? I'm sure a lot of lazier QAs would just add more resources. Greater than one or greater than two.
Yeah, so I mean, the question is, since it's so easy to scale up, and you can see if you need to scale up, then it'd be easy for somebody to scale up. Yeah, I mean, that's one of the uses. I mean, if you, but then you're gonna, it depends who your manager is. Can your manager might push back and be like, no, we don't want to spend more, optimize the code. So, but yeah, but I mean, that's what this is for, and I think it's really cool because like, databases typically have been a black box. I mean, it's fun watching. I mean, when I work with the Oracle people, Oracle have had this stuff around for 10, 15 years and like, give me more. I'm like, yeah, I understand where you're coming from. I want it too. But then I go to Postgres or MySQL and I'm like, wow, I've never seen what's going on. This is so easy. So then that's really fulfilling. But yeah, the idea is if it's, if the graph's empty and it's always empty, well, you're on too big a machine. If the graph is always over full, then you're probably on too small a machine.
The spikes that you see are not related to CPU, then say that you can pretty much ignore the max CPU line?
No, so the question is, when the color is not CPU, can you ignore the max CPU line? No, for me, the max CPU line is always a point of reference. I mean, if the load's higher than that line, that's an indication to me like that's probably a big bottleneck. And whenever I go above the number of CPUs, I know somebody's waiting. Somebody has to be waiting. And then the question is like, another thing to think about is what's the ratio between CPU and weights? If weights are 4 times as big as CPU, then if I can eliminate those weights, then I'll 4 times my throughput, right? So that ratio matters as well. But yeah, whenever I see a spike up above the CPU line, I'm like, oh, there's a bottleneck. Let me look into what's happening.
So does a vCPU correspond to a core or a CPU? Because that's a really important difference, right? For a core, isn't it?
It's a thread on a core. For me, well, the thing that I like, this corresponds to my percentage CPU usage. Like if I look at the percentage CPU usage on the operating system, if I have 2 cores, 2 vCPUs, which this does, when I'm at 1 active session, then I'm at 50% CPU, roughly. Yeah.
Well, I don't know. I generally have found that, especially on EC2, that a vCPU is basically, as far as I understand, Amazon or EC2 hyperthreads at 2 per core.
Yeah.
2 hyperthreads per core. Right. So I always measure a vCPU on EC2 as being half a core.
Yeah, that makes sense to me.
So, I mean, the thing is,
you could, I mean, yes, it does get tricky. You could be.
I mean, we had 2 arguments that worked with one, especially about what the board. So in the end, we put both lines up there and let the user pick. But my rule of thumb would be put it at cores, and if your green goes above the core line, you get lucky, right? Have a good day. But I put on a process-oriented software like Oracle. It's not multi-threaded.
Yeah, your advantages are much lower. Right.
But in these virtual environments, we don't see beyond vCPU. We don't see cores. We don't see, right? Threads.
You don't see them, but we can display it. I mean, we actually had it in there. We took it out because it was just like, I wanted people to use vCPU, and the cores was confusing. So like, let's just take it out. Any other questions? Okay, thank you. What?
Hey, Kyle, how do you see this changing in serverless database environments? The server process spawns up to run a query, shuts down, gets allocated to the host. How do you really bake in monitoring that?
Well, I mean, it's the same. I mean, it's the same basic idea. I mean, we would collect. Basically, what we do right now is when you destroy an RDS database, the performance data goes away. That's just the way we start out. But once we start saving it, then once you have serverless and it goes up and down, you save it, and then you save it. We need, and also one thing we're working on is an aggregate dashboard where you'd have a bunch of instances all rolled up into one dashboard. So that means that's the path. First, we need to save it after it's gone. And then second, we need to build an aggregate dashboard. So yeah, it should be cool too. And I mean, we have all these, like with Aurora clusters, we want to see all the nodes as well. So it's all the same work.
And do you see, in order for Arch, you can see if you have one execution taking a long time or many short executions. Yeah. Do you see something being able to do that in other databases?
Yeah, no, we'll definitely be able to do that in all the farther know in all the databases. Yeah, at Amazon we haven't implemented it yet, but we're working on it. Yeah. Anything else? Okay, thanks for coming.